In this video, I'm going to go over the solutions to the exercises in problem set 3. So in general, I just graded them and they look pretty good. So not too much to complain about. So rather than develop them entirely, I'm going to go ahead and just show you what I've got and walk you through my solutions. Again, some of you had different solutions, different ways to approach it. Perfectly okay. As long as it works, life's good. In fact, some of yours are more efficient than mine. There's always a short versus how you're thinking about problems kind of thing. Okay. So I did want to go over the revision of the point type program. Okay. So the point type itself is not really much of a big deal, but I think the issue for some people still are having an issue in the two that derive from that. Okay. So we've got the circle type CPP. Okay. And I think where people ran into trouble. So most people were correctly this time. I mean, last time it was kind of an issue, but this time you are getting or most people got, I think everybody got the inheritance part of it, okay? And most people were pretty good, but I think the issue for some was that the subclass, in this case, the circle, has to call the point type class, okay? So the circle class can't directly access the X or Y coordinates of the point. Okay, so they have to call that constructor. You have to put all three of them here in your call because that's all you're going to be getting. That's what's coming in from the outside. But you pass along what you can't deal with and deal with what you can deal with. Okay, so you set the radius, which you have access to because it's in this one, but you can't do the others. Okay, the X and Y have to be sent on to the superclass constructor. Okay, and in a similar way, the cylinder type inherits from the circle type, okay? And again, its constructor has to call the circle type constructor with those three things, okay? So again, when this calls, since we're doing a point class, or I guess a cylinder class is a circle, is a point, that the cylinder type constructor sets the height, which is what it can do. It then calls the circle type with the X, Y, and R because it can't deal with those. Okay. The circle type constructor would then set the R and then send along the X and Y to the point constructor. Okay. So the cylinder is going to call all three of those. Okay. And yeah, that's the only really issue I saw with people having on this particular one. Okay. So let me take a look at the other two. Again, I think most people got these as well. Okay, so week 3 solutions. Okay, so we'll start off with our C6P8. Okay, and that's the reverse digit program. So this one, the way I chose to do it, and I think no one else did it this way, but that's okay. This will be a different example. Instead of just dealing with integers, with numbers, which you certainly could do, I didn't want to have to worry about multiplying the powers of 10 back in, okay? So I just converted it to a string, okay? So I'm going through here, and I'm doing just I'm getting the idea on the recursive programs, I have this recursive step, okay? So I'm getting that the reverse of 1, 2, 3 is equal to the reverse of 2, 3 plus 1. Okay, and then my second call, and then my third call with the base case with only one digit. Okay, so I kind of lay all this out. Okay, so it was important for me to get that on paper. Okay, and that's way more comments than you would need. So for me, I'm including the IO stream as we always do. Okay, and I'm including the string and the CMath, although I'm not sure if I used CMath. Maybe I did. Okay, so for me, this is my reverse digit program itself. I take in the int n. And I created a lot of integers here. I've got the number of digits. I've got the first digit. I've got the rest. And then I use P for something somewhere along the way. Okay. And then I've got my string S. Okay. So I'm just doing the toString function, which is, I think, part of the string class. You may have to include string to do that on n. So that takes my number. If I have n is equal to 1, 2, 3, it's now equal to the string 1, 2, 3. Okay. And then I can then get the digits directly. Okay. So rather than having to go through and loop through and do a little loop and divide by 10 every time, I can just figure it out directly from the length. Okay. So here I've got my base case here. Base is that there's one digit. If so, in the STOI function, it's just a string to integer. Okay. So it's going to take the string, the whatever one digit we've got, okay, that's a string, and return it as an integer. The return type of this is an int, so I have to make sure I do that every time. Okay. Then for the general case, okay, so it's not one digit. I'm going to start by capturing the first digit and then setting it to setting the rest of the function. Okay. So here is where I am setting this p-value, okay, to get the right number based on digits, so I know what to divide by. Okay. So this is 10 raised to the power of digits minus 1. So I can then get that first digit, no matter what gets sent in. Okay. I can get to digits because that's a variable here in this program. Okay. And then that gets me my first digit, doing the integer division, and then using the mod, I get the rest of my digits. Okay. And then the recursive call, once I've set all that up, is to call, I get an S. It's going to be a toString on the reverse digits of the rest plus the toString of the first digit. And then when I'm done, I just return that. Okay. Then my test program, I just have them enter an integer and then do the reverse. Pretty straightforward there. Again, it's a different way to do it. I don't know if it's easier or harder, but just what I felt like doing. And then the other one is the recursive powers. Okay. So we already have in the math library a power function. Okay. So, and it should give exactly the same results. So I went ahead and included that so I can test them side by side. Okay. So just to show, when I was testing out, I just left my code in here. I put some kind of a symbol at the top so I know it's stuff I want to get rid of later. But I want to know when I'm in the function and what X and Y are in this case, just so I can track. As it's doing recursion, you often want to see what's happening behind the scenes. So that's going to pop up. If I uncommented that, it would pop up every time that I went through. Okay. And then we've got base cases here. There's more than one. Some of you use a switch here, and that's fine. A switch would have actually made a little bit of sense. So if y is equal to 0, you just return 1. If y is equal to 1, you return x. Okay. And then a couple of general cases. If the y is less than 0, then you're going to return 1 divided by the power of x over minus 1 times y. And it wasn't working, so I had changed it from a negative y to a negative 1 plus y times y. I don't know that matters. I think some of you had a negative y that worked. That turned out not to be my problem, but I just left it. Okay. Else we're going to return the normal one with the power of x times the power of x to the y minus 1. So if I have x cubed, this would be x times x squared. Okay. That's my recursive call. That will go down to 1 eventually. So then we can return just x. Okay. Then to test it again, I just tested it out. 5 to 0, 5 to the 1, 5 squared, 5 cubed, 5 to the negative 2, and 5 to the negative 20. Okay, just to show. Okay. And some of you kept the x and y as integers, which is fine, but know that the results, because when I did that was my first thought. When I did the negative powers, I would get a 0 every time. I'm like, why am I getting a 0? Well, because it's less than 1. And it does that integer division. 1 divided by returns a 0. So you have to either do something special with the output, or I just made everything floats. Okay. But just to show you these here. First one here. Enter 1, 2, 3, 4, 5. And it gets me 5, 4, 3, 2, 1. Okay. And then the other one, again, you could ask for input, but that to me was going to take a little while to test it. So this gives me a better test. So again, and I should have put a label in there, but on the left is my power function, and that's versus the CMAS PAL function, just so I know that things are working correctly. That's a way to check it. Okay. So that's it. A pretty short video. I didn't go through the development because people seem to have gotten it okay. But as always, if you have questions, make sure you let me know.